on this the real zeros polynomial. Okay. So what is the application, or what can you do from the real zeros polynomials? So this is really essential. Even I could say it's really helpful if you want to find zeros for every polynomial you can find. What you can do first is taking the p over q over here. We call this a directional zero. This p over q. P means that it's the factor of the constant coefficient of the first or the last term. So if you have a polynomial, if you order the constant from the highest degree until the constant, then the constant will be the p. The q is the first between the highest degree. So what does it mean? It means that the p is actually a factor. For example, a factor of 2 is 1 and 2. A factor of 5 is 1 and 5. A factor of 6 is 1, 2, 3, and 6. It's possible for each numbers to be multiplied and makes it resulting to 6 for the final number. Okay? And then we divide with the factor of q. So the result is we have some possibility. And based on the possibility, that will be our roots or our zeros. Okay? So when you are finding your zeros, before you are dealing with, or maybe you put in the number into the functions, you can do that. And then you can also try the Descartes rule. Okay? Perhaps the sentences is quite ambiguous, or maybe too long, too much words what is it. But the way we are taking the Descartes rule is actually we take any variation in the change sign. So if you have a polynomial, let's say, maybe let me just let me write some polynomial. Let's say we have x, or maybe this is px, x cubed minus 2, x squared minus x plus 2. So from the Descartes rule, we can see that this is positive. Right? This is positive, negative. Okay, so we say this is changing, right? So we numbering this part 1. Okay, and then from this negative to positive here, so there are 2. Okay? There are 2 changes, which means in this positive 0, we say this is positive 0. So we say the functions px have 2 positive zeros, or as actually mentioned in the definition, less than that by an even whole number. So actually we need to minus 2. So, or 0. Okay. So what does it mean is actually we have a path that says that, okay, it has 2 positive zeros. And then we have another path that says there's nothing. There's no positive zeros. Which one is true? We don't know yet. This is just to give you some impression. What the roots? So you have one path, second path. Okay. Now we could check the other roots, the negative x. We see that only 1. Right? So from negative to positive, there's no other changes. So this is 1. So for sure that the px has 1 negative 0. So if we want to make like a conclusion from this Descartes rule, the first root says that, or maybe let me write with a table here. Let me make a table.
The first says that the positive zeros have 2 or 0, right? So we have two roots. But the negative, it's only 1, so 1, 1. It is a cubic, so it should be having 3 solutions. So it should be total 3. So for the second root, maybe there will be an imaginary number, a complex.
Okay, so there will be these two. Okay. But what is the zeros? We are not don't know yet. We just narrowing our answers. This is like an observation, like a deduction, like you are a detective. Okay, you found something. Okay, and I think like mathematics is about that. You find identifications, observation, and then deduct everything, and then make some conclusion. Okay, so you are not starting like take random things and then just compute, calculate. They're just like using brute force to like calculate everything, and then somehow like when I looking the answers from students, usually if students they are not knowing what they are writing, sometimes they are just okay, they write something, and then I'm not sure how he find the number, whether he just put like some formula, maybe just random formula, and he just wow. It means that he doesn't understand the question. Like, if you want to deal with mathematics, first is understand the question. Like a quiz, understand. Like, I think the first two is about circle. Circle, what is circle? So first you need to think the formula that is related to circle. Okay. After that, then you can pinpoint which part that is being asked. If it's asking to make the equations in a circle equation standard form, it means you need to tweak something in the equation, making maybe completing a square or something else, then do that. Okay? So you are making some deduction. Okay? You are making like identify, observing, and then deduct everything, and then write some conclusion. This is pretty similar. We're narrowing like the Descartes rule can be skipped if you want. Like you can just take some time to do some maybe some trial and error. That's also fine. But this is like I think like an elegant way to show you. Oh, we have like two possibilities. Okay? Two possibilities that can be our path, okay, for ongoing. Okay, now we find this, and then still, if it's asking about the real zeros, then we need to check the P and Q, right? So P and Q, so P is 2, right? And Q is just 1. So the P over Q means the factor. We only have this, okay? So as a numbers, this is actually pretty easy if you just simply trial and error, okay? But for sure, if it is more, then I think the long division or the syntactic division in the polynomials method will be, I think, helpful, okay? Also, that is helpful for your calculus, okay? For your midterm. Okay, so we take 1, -2, -1, 2, just reviewing the syntactic division. And then we can start maybe just 1, the easiest one. 1, 1, 1, -1, -1, -2. Oh yeah, we get 0, which means that 1 is our zeros. So, as a conclusions, we can make, because it's cubic, so the rest will be quadratic, so we can just write the px is x minus 1, right? This is the factor 1. Multiply with the quadratic x squared minus x minus 2, right? And I think we can factorize this. And then we get x equal 1, x equal 2, and then x equal -1. So the first root that is fit with the final answers. And so you can just try put into the functions one by one. It's just a combination of 6 numbers, or not 6 numbers, only 2 numbers, like 2 plus minus 2 plus minus 1, only 4. So basically just try one by one to the equation. I think still. Do you have trouble with the cubic or maybe with the higher degree than that? Doing this, okay? Would be helpful. Yes?
How do you get 2 for the imaginary number?
Because it's a cube, it should be 3 in total, right? So the most possible way is to take imaginary number as 2. Oh, Richard? Okay. So this is based on, this is the positive zeros, negative zeros, imaginary number, zeros, and this is the total of the zeros, or the roots. So basically, this is based on what we have here. So the positive zeros has 2 or 0. 2, 0. Okay? And then the negative zeros is always 1. So every root is only 1. So 1, 1. Okay. The total, since it's a cubic, should be 3, right? And then it's basically 2 and 1 becomes 3. There's no imaginary number. Since this is 0, this is 1, this is 3, then this should be 2. There will be 2 imaginary numbers. This is just a possible way. The possible way. Okay. Okay, maybe giving you one more example. Okay. Or any question? Any question?
Okay. Okay, let me give you one more example, and then we can go for the next part. Let's say we have px okay, question is find how many possible roots of possible zeros, and second, find zeros. Determine the number. Basically, it's the same question as the previous one.
The previous one I forget to write it. I think the first half I will just getting in the sections, all the polynomials, and after that the second half will be most likely the exercise.
Okay, so first, the question how many possible roots is basically it's asking the Descartes rules. So you will see that we have one change here, right, and then 2, and then 3. I believe we can finish around 8:15 or 8, yeah, around 8:15 or 20. Okay, is that okay? Okay, so we have 3 positive zeros. So 3 positive zeros, or we need to take -2 or the even number, or 1 positive zero. Okay. And then we take the negative x inside. All negative, which means that there are no negative zeros. Okay, so we can make positive, negative, imaginary number total. It's the same cubic, so the total should be 3. So the positive 0 is 3 and 1. The negative is 0, 0. So either it's going to be all positive zeros, total 3, or 1 positive 0 and 2 imaginary number. Okay. And then you could say we could find the, let me write here, x cubed. We could find the possibility of the zeros. So based on this is 10 and 1. So P over Q is basically factor 10 and factor 1. Factor 10 is plus minus 1, 2, 5, and 10. And factor 1 is just plus minus 1. So we have 4 combinations, or 8 in total. I think 8 is too many. So we could start taking the positive one, because we know that there will be no negative 0. So we can focus on the positive one. So we can write synthetic division 1, negative 6, 13, and negative 10. So let's say we are taking 1. So let's start taking 1. 1. I think no. So let's change. Let's change 1. 1 is not. Let's take 2. I think we get it. I think we get it. So we can take and factor the x negative 2. And then that will be, this quadratic one will be x squared minus 4x plus 5. Okay. Okay, can you factor this? No, right? No, right? So 1, 5. I think it's not factorizable, right? So what should we do? So let me write here. So suppose f of x is okay. Suppose we are going to try to force factoring it. Okay. So we are taking this, making it equal 0, right? Why? Why need to make 0? Because it's usually we factor equation. Why we need to equal it to 0? Why? Okay. Why? Why? Why we need to equaling it to 0? So usually you did the factorization, right? And then you equal it to 0, equal to 0. Why? Yeah, why? But why 0? Why? It's really basic. Yeah, but what is 0? Yes, the intersection. The intersect. Okay, that's really basic. The way you find in the sketching curve in calculus is you also take x equals 0, y equals 0, and find whether the curve is going to cross some axis or not. Okay. So this, remember the quadratic equations, like normally, like our normal quadratic equations, like we can start with the, let me just review this really quick. So we usually, we start from here, right? The x squared, our y, trying to make it curve. Okay. Okay, let's say that is y equal x squared. Okay. Now, if I move the x squared, actually this x squared, maybe here, maybe 2 units. So I need to, if I move this downward 2 units, it will be, the new function will be x squared minus 2. Okay? Okay. So let's say this is going to be moved here. So let me just write with the red color, like that. And then suppose that this is the new curve, which is x squared. This is let's say y equal x squared minus 2. Okay. So y is called the roots, or y is called the zeros, because it is here. It is where y is 0. That's why we want this to be 0, to find basically this 2. Okay? You get it? You get the fundamental concept? Okay. So basically this is the one like you do the factorization all the time. It's actually finding this. Right? Okay, got it? Okay. So back here. So now the way we factorize, of course we cannot factorize like in a regular way, but if suppose that we do this. Can we do this? I will move -5. Okay. So I move 5 to the other side. And then we can make a complete square. The complete square, if you remember, defined by 2 squared, so with plus 4. But remember, in math, you have an equation. If you do something on the right side or the left side, you need to balance it with the other side as well. Okay. Otherwise, you change the whole thing. Okay, you change it. So if I plus 4 this part, so I need to plus 4 over there. Okay, and this is also the same way you can find the complete square in the circle equation in your quiz question number, I think number 2. So from this part, we get x minus 2, right? Squared equal -1. So this is, I think this is the problem, right? And now I will introduce you to what is this. So we call this, so if we want to take square, the square of -1, this is what we call the imaginary number. Okay. So let me write here. So the I squared is -1. So the I is actually this. There's also interesting thing about this imaginary number. So it's imaginary, but we can sort of find the relation, the real number and the imaginary number. It's something we call the Euler formula, but I don't think I need. You need that for now, but you need to know later on. Or if you want to find out what is the relation between the real and the, so it's called imaginary, but somehow like we can make like in axis, like this is the real number axis, this is the imaginary axis. There is somehow there is a way to do that, but maybe that's for another talks. Okay, it's not basic basic of my. Okay, so change the topics. So anyway, based on the definition, then we can write this as just plus minus I. So x is 2 plus minus I. So we can have 2x, that is 2 plus I, and then the second x, or maybe x1, x2. The other one is 2 minus I. So now, to solve this, you can always rely also on the quadratic formula, which I don't really like to write. But I think you memorize it, right? I try to forget this formula. You memorize it, or all of you know, right? Already from one. Yeah, that things we teach. Like, do you know the formula for area for triangle? Yeah, half base times half base times. You also memorize it. Like, if like, so if you have a square, oh, it's really bad. Let me redo the square. Okay, so if I have a square with, let's say, A, like that. This is A squared, right? The area is A squared. Okay. If I take a slice, then the area will be half A squared, right? If I take a rectangle, let's say this is A, this is B. Just take a slice. So this area, so area of rectangle is A and B. Just multiply, right? So this is the, and the triangle is half of it, half AB.
like if you want to teach maybe your sister or maybe nephews or small nephews, it's much more interesting to teaching them from here rather than triangle is half base and height. Very bad for your own critical thinking. Very bad. But if you teach from here, your kids will be more curious and then, oh, I see that it has more connection. I can relate to math all the time. But anyway, I found this interesting because I also went through the same like loophole, same cycle. So I want to try a new approach. Yes. Oh. You mean the whole thing? Okay.
What if it's an isosceles? If it's an isosceles, can it make that?
Pretty much. Still, there's some way to take it. You can make it like from here, from here. Okay. You can try to cut and then see the connection. I mean, as a starting point, it will be very, very good approach.
So the conclusion here, the roots that this function is going to take is there will be 1 positive 0 and 2 imaginary number.
Okay. Any question before? Yeah, it's basically part of the rule of signs that is actually trying to be explained by this Descartes rule. So the Descartes rule says that the number of positive or negative real zeros is either equal to the number of the variation in sign, the sign change, or is less than that by an even whole number. The even whole number we define as is 2. So you use minus 2. So for example, if you have 5, so 5, 3, 1. Okay.
Okay, just quick notes. The fundamental theorem algebra. It says that every polynomial
With complex coefficient has at least one complex 0.
and relate to the let me check first. Have we tried? So any real number is also a complex number as well. So this theorem will be applied to polynomials with real coefficient. Okay, so the same thing. And then if we think in the factors, so if we factorize like even further, so if the px is any polynomial, okay, with degree n more than 1,
there will be a complex number such that when we are factoring, this complex is inside this factor. So when we multiply, the complexes become real.
okay. So it's actually like, I think let me just give you some example. Okay, so if we have this, okay, if we want to try to factorize, now this is interesting. This is, I forgot what is the name, the terms.
But if you see how the structure, so it's x cubed, x squared, and then x, and then minus 3. See the coefficients 1, -3, 1, -3. And then it has cube and squared. So if I take squared outside, it will have x minus 3. It also has x minus 3. So we can take factor x minus 3 outside. So
we can do this actually. Very interesting. So sometimes you can do this. Okay, so I take x minus 3 outside. This will be x squared plus 1. Right? So this one is a real, right? X equal 3, but this one is basically -1. So the x is plus minus imaginary number. Okay. So the zeros are 3, I, and -I. So we can put this factorization as x minus 3, x minus I, x plus I, in which this is actually what this theorem says. Okay. So basically, because we multiply like all the things inside, so the imaginary is gone. Okay, it become -1. There are some sections related to this complex, but I don't want to delve into that much. So I just want to say that if you have, like in the polynomials, if you find this situation, sometimes the zeros can be imaginary. Okay? The other terms that might be useful, at least for your calculus. Okay. There will be, we call linear factors and the quadratic factors. This part, that what we did before, this x minus 3 we call as a linear factors. The x squared plus 1 is the quadratic factors. So this will be the linear. This will be the quadratic. And the interesting part in this quadratic, we call the quadratic as irreducible quadratic factors, which means that it's not factorizable to be the real numbers. Okay. So this is irreducible. Let me write here more clear.
This, I believe, will be at least in the second half of calculus 1. Pretty much maybe you will see this term when we deal with the integration, especially when we are in the, we call the method as a partial fraction. And in partial fraction, you will see that there will be a linear and then there will be a quadratic fraction.
Actually, partial fraction also in basic math if we have time.
I mean, in the course, the whole course, if we have time, we can also get into that partial fractions. is actually in the chapter of the matrices, or the system of linear equations. It's like introductory of linear algebra. Like, if you maybe have a passion in programming, that should be one thing that you need to at least know beforehand. The matrix and the linear equation.
Okay, that's it for this polynomial. But in the same sections, there's also mentioning a rational function, which I want to just review because it's also, I think, very essential, especially with your calculus, sketching curve things. Okay, so let's go to that. So rational functions is basically any functions that start with, let me write as r equal p of x over q of x. Okay.
Why these rational functions in the same section with the polynomials? And notice that I write the same p, q, same thing with the polynomials. Because when we deal with this, and if we apply long division in polynomials, we're going to rewrite this with different form, as we did in polynomials. Okay. That's the thing, that why this rational is actually related to polynomial. Because rational is basically we define the function, right? We define the function of the function of that. Okay. Now the basis for the rational function is we can see the 1 over x, function of 1 over x, and that is the very essential one. This is 1 over x. Okay. And since this is basic of math, which pre-assumption not yet learned in calculus, but since you have learned limit, we can also prove this using limit. So we take x as large as possible. Then we see that as x going to the right is going to close by the x, right? Or it's going to be y equals 0, which we see that later. This is we call the asymptote. This is also the asymptote. So we have the horizontal asymptote and the vertical asymptote. Okay. It must be in your midterm. Finding the vertical asymptote and the horizontal asymptote. At least in the sketching, you need to be able to define that. Okay? So this is asymptote. And this is pretty much the behavior. You can see the behavior taking some numbers, and you'll see the correlation, okay, why this is going to be true. Okay?
And if you see the domain, since this is just 1 over x, and if you see the graph, then we can just state that this will be the domain. Okay.
So domain is like, it's not just only a number, but it's a set of numbers that is possible to be put in the function. So, like if you have doubt, maybe not sure whether it's correct or not, just try some numbers, which is it's like you have an interval. You can try the interval. So that's why I'm always emphasizing draw a line number. But most of you didn't write the line number in the quiz, so I'm really disappointed. So every time you have an inequality finding domain, just draw a line number. you get the numbers, right? You get the number, but you're not sure whether this is the number or this is the interval. Draw the line numbers, put the numbers, try the interval between. And you can, oh, this is positive, negative, positive. And you can relate. What's the question again? Oh, we need to find the negative one. Okay, we take the negative one. Or maybe the positive one. Okay. Okay.
Okay, or this or range. We can also have range, which is y is not 0, and basically the 0 is the asymptote itself. Okay, and then since we learn the asymptotes, I think this is just emphasizing what you have learned in calculus as well. So I think not really much.
So you can just look at how we could get this A as an asymptote, because if we take the A from the right, okay, so if we take A from the right and then we follow the curve, it's going to be infinitely large, right? And then if we take the second picture, it's also the same. The third and then fourth is going up, which is leading to negative infinity. And similarly, for the horizontal asymptote, we take the x. Now we can take x as it's going to be infinitely large, and then it's reach this y equal b. It's getting close. The same thing with here. It's also getting closer to y equal b.
And of course,
In function, we can always transform the function. So this fractional function, we can shift, we can move to the right, we can multiply, we can factor, right? Okay. We can mirror, we can reflect it.
Right? So we can do that, all those things. So we can write, let's say, ax plus b, cx plus d. Okay. So graph f of x, 1 over x, can be shifted or transformed. Okay, so let's get into this. So if we want to graph this, like 2 over x minus 3, okay? So the first one we can think, this is from here. Okay, or we could think this 1 over x minus 3 as 1 over x and then move left or right? Right, okay. So we can think this is the same as this. Okay, so if f of x is 1 over x, so this means that f shift to the right 3 units and stretch by a factor 2. How about the second one?
How about B? 3x plus 5 divided by x plus 2. Since it's a linear, it should be able to be restructured as 1 over x. I mean, 1 over x can be shifted and then make this. So what can you do? Remember, every division in polynomials, we can just define it. Okay, we can just define it.
So just define this. I mean, we can just do this. Elementary school. 3, and then 3x plus 6. Okay, then we can write that the function can be written as it's 3 plus minus 1, so minus 1 over x plus 2. And this is
so the function move to the left 2 units, reflect it, and shift upward 3 units. Okay.
so f of x is also 1 over x. So let me write as a conclusion here. This means shifting or f shift to the left 2 units, reflect in x-axis, and shift upwards 3 units. Okay, now this is the picture for the first one, and this is the second one.
And then based on the functions, since it's in the denominator, we can tell the asymptote easily. In your calculus, if you need to tell the asymptote, don't forget the limit. Okay, you need to state the limit. Okay. And then the second one, the vertical asymptote, easy from the denominator. It's x plus 2, so it will be 0 if x is equal to negative 2, right? That is the one that we don't want, so that will be the asymptote. It means that the curve will not be able to cross this line. Okay, that's the asymptote it means. And then how we get the horizontal asymptote y equals 3? Actually, in this part, in this equation, it's very easy. The highest term in polynomial. So this is x, this is x. 3, 1. So it should be 3. In your calculus, this is actually take limit as x approaching infinity. Divide by x, this becomes 0, this becomes 0. So 3 divided by 1, so 3. Okay.
What I mean is this, okay? This 3, this is 1, okay?
And then the rest, you can ignore this one. Okay. Or if you want to make sure, take the limit as x approaching infinity. You will get the horizontal. Okay.
Okay. Do you want to take notes here?
Oh, the previous one.
The previous one, you mean? Okay, okay.
Okay, any questions? Questions? No? This one? Since there is no variable here, it will be 0. Or if you want, you can just you can take limit. Take limit. I think it will be very much convincing.
I see.
Okay. There is one thing here, but I think I will just skip this for a while. This is also I will skip for a while. I will move to this inequality first. Which one? This one? Oh, by the way, periodically check your Moodle. Right? Okay. Next week, no class. Okay. Several days I will be off for I have some invitation to go somewhere. Also calculus, you have I think 2 hour tea. Okay. I will announce also later in Moodle. Okay, so that's I think you need to check your Moodle every time, at least every few days. Okay, I will go directly here just to make sure that we are on the same page. So this is actually some steps. If you think that is too much work to read, then we can just go for exercise. I think exercise is better than just reading that. Okay, so then let's say we have this solve the inequality, blah blah blah. So very quickly, I will start with taking all on the same side. And it's polynomial. Okay. So we have this polynomial. What you can do? You can ignore this. And then start factor this. How to factor this? Do the polynomial things before. The rational zeros, blah blah blah. So you have 6, 2. So factor of 6, factor of 2. We can take that. So plus minus 1, plus minus 2, plus minus 3, plus minus 6, plus minus 1, plus minus 2, right? And if you want, you can write with another, let's say you name your function h. And you define your function as this. And then you see that we have this 2 change, right? 2 change. So 1, 2. So 2 positive zeros. You can also check the negative x. Only 1 negative zeros. This is 2 or 0. Sorry, I forgot to write 0. All right, what next is, this is actually over, forgot to write. So it will be 1, 2, 3, or 1 over 2, and 3 over 2, or 3 over 2 should be here. 3 and 6. Okay, there will be 1, 2, 3, 4, 5, 6 combination. So or 12 numbers. So we can start taking the negative. Take the negative. So we take the synthetic division. 2, 1, negative 13, and then 6. So we can take negative 1, I don't think so. Take negative 2. Let's say the I will skip the partial the fraction. I will make them last one. So 2, negative 4, 6. This will be what? 7, 40. Oh no, I don't think 2. Let's say 3. Oh, interesting. 2. Okay, we got 0. So we can write the function as x plus 3 2x squared minus 5x plus 2. Can we factorize this? So this will be 2x, x should be 1 and negative, right? Okay, so this will be 2x minus 1, x minus 2, okay? So the zeros are negative 3, half, and 2. So this is the number that is expected. And what should we do now? Take the line number. I will write it up here. So we start from negative. So negative 3 half and 2. So what is our goal?
Our goal is to make sure that the whole x thing here is equal or greater than 0. Okay? So we are going to include all those numbers because it's equal or greater. Right? So we can check the interval. Here. Check the interval.
Actually, you can just check this. Okay, I think
this is pretty bad if you want to check. I think just use it.
so you can write. It's much make your life easier. So you can write all this. We want to make this. Okay.
So take negative 4. Negative 4, negative, 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 positive, negative, positive, negative, positive, negative.
Okay, this will be negative. And then we can take what? We can take 0. So take 0. So positive, negative, so become negative, 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 it's positive. Or no? Positive, right? And then we can take 1. 1 plus 3, positive, 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 negative. So it's negative again. And how about 3? 3 will be all, I think, negative. Oh, positive, all positive. Okay, so which one? We want to have the positive one, right? So that's your answer.
So really helpful, right? Line number. So every time you have an inequality, draw the line number. Draw the line number. Do not make your life suffer. Because you try to conclude everything like from the equation. Oh, this is this equals 0 or maybe greater 0 or less 0. But then your conclusion is wrong. Like I put all the tricks in the equation, so that's why if you are not dealing with the line number, you will not be able to see the interval. I deliberately dealing that to you. Okay. So I hope it's interesting.
Okay, if you want, you could try the
second one, in which there will be one term that is irreducible, which in this case you can skip that and focus the one that makes zeros, and then doing the same thing. You can try this one,
but I prepare another one. That will be our section, our last sections of today's class. Okay. Okay, let me go through another. Okay, wait for a while. Okay, you could, if you want to take photos, you can take photos this. You can try yourself. If you want to apply your calculus to sketch the graph, you can try as well. Okay. Just to make sure that you understand. Okay. You can try. This one, you can also try, but I would like to start after this one. Okay. Maybe later I will give you how the final answer. But I would like to start with this one. Okay. This is the rational inequality. Rational inequality. What is the essential things in rational inequality? Rational, as you may observe from our previous slides, we have two equations at least, right? The numerator and the denominator, right? And the one that is on the denominator is, it will affect your domain, right? It will affect your domain. In which so if you try to cross multiply, you will lose some conclusion. So try to make this fraction stay as it is. So one thing you can do is, you can put this 2 over 3, take to the left, so minus 2 over 3, and then combine them together, so we still have a good fraction. Okay. So that we still have the domain that is going to be essential here. Same thing with this. This 4 over x
since this also has a variable x, right? So do not cancel this x. You will lose some solution. So the plausible way is to move this to here, and then you can combine and still have a good fraction, but maybe big fraction. It's better. Okay? So let's try doing that.
Or any, you can try yourself first. Okay, I will give you some minutes. Try the first one.
Any volunteers? Group 3. Which one is group 3? Group 3? Anyone from group 3 want to try? Anyone from group 3? Or group 4? Who is group 4? Who is group 4? So you can think, because this has like equal 0, this has like equal 0, so you can find some x that is can make it 0 from the numerator. And from the denominator, you could think the domain. That is also will be in your the domain will be very small. Yeah, and then what else?
Okay. Okay. This we can start by taking to the left like that, right? And then taking this 3x plus 2. So you may be confused. What should I do after this?
So first, look here. We have 7x minus 1 in the top, right? So if you see this is a fraction, the way that we can make this whole thing x0 is just the numerator, right? So you can think like 7x minus 1 equals 0, x will be 1 over 7, right? The one thing that can make this whole formula become 0. Okay. So let's try
to write that first. So first, we can think that this is, let me just write that first. Okay. So x is 1 over 7. Okay. And we also know that this one, this x plus 2 should not be equal to 0. So x should not be negative 2.
From this conclusion, we have two numbers that we need to be aware of. Okay. This is also important in your calculus. Sometimes you will find this rational. Remember, like when you make the critical point, the inflection point, you need to make it equal to 0. So to make sure that we have the numbers, we need to think numerator and also denominator. And those two numbers, if they are essentials and important, then we need to make into our intervals
to find which interval that we need to take as a solution. So we have -2 and we have 1/7. So we can think from
maybe -3. -3 here, negative, -3, negative,
it will be positive, right? So this will be positive. In between, let's say 0. So if you put 0, the top is negative, the bottom is positive, so negative. So take 1, and let's say x equal 1. So positive, positive. So it's positive. So which one is the answer? The negative, right?
Okay. But careful, since this is not equal -2, then we need to exclude and not include.
So solution is -2 and then 1/7. We need to include, okay?
Okay. Like imagine like you are like a detective. Like you deduce things from here and then make some conclusion, draw a conclusion. The calculation thing, actually math, is not as important as understanding our identification. As long as you can identify what is this problem, you can solve it. So here's the thing. You have the top equation, you have this bottom equation.
Just from the 7x minus 1.
Yes.
Just add it. It goes to 1/7. Just like that. Like we'll have to.
Yeah, if you put 1/7, what happens? If you put 1/7 here, what happens? If you put x equal 1/7, what is happening here?
7 times 1/7 is 1.
So 1 is 1?
0.
Yeah, it's 0. Okay? Okay? Okay, think here, you want to make it 0, okay? But the down equation here, the bottom one, supposed to be not 0. So there's two things, right? So the one that makes 0 and not equal 0. Two things that we need to include inside our interval. Okay? So that's why we have this. But this -2 should not be included because we don't want it. Because if we put -2, it will be 0. So that's why not included. Okay? Okay, so that's why your quiz is very, very bad at that point. Okay, actually,
do you want to
one more or
to finish? Finish, okay? Finish, okay? Maybe you could just take picture of that and then you could try later, okay?
so that means I need to check again your concept on this one. I think some students like email me, I can't do it right. It's okay. Just email me. Give me a lot of emails. And then I go,
Just email me, okay? Just email me. Okay, that will be the